So as we discussed, there are two types of method are there. One is method of section and another is method of joint. So so to analyze so to analyze any type of a frame structure, any type of truss member, we can go through any one of the method. This is a method of joint, either method of joint or method of section. As we discussed, there are two type of method are there. One is method of section and method of joint. So each and every method has their own calculation process. With this calculation process, we can analyze any type of frame structure and analyze the member force in each and every member of the truss member. So what can we found from this method by analyze a truss member? So first of all, we have to calculate forces and each and every member. So here 1, 2, 3, 4. If we consider this is a 4-member truss, so by applying method of section or method of joint, we can easily calculate the forces at each and every member. So here AB is a member, BC is a member, CD is a member, AD is a member, BD is a member. We can easily calculate member force at each and every member. Also we can calculate which type of force it is, means if is it a compressive force applied to the member or is it a tensile force applied to the member. So here is an example of one simple truss, that the span of the truss is 4 meter and height of the truss is 1.5 meter. Now one load is applied at 8 kilonewton horizontally at the point of B, and one load applied 12 kilonewton at point D in downward direction. So to solve this type of task, we have to first analyze the reaction force. So reaction force, we will found the reaction force at the support of the truss member. So there is a two support. One is at A point and another is at C point. As we earlier discussed, at A point this support is called as a hinge support. In this C point this support is called as a roller support. So we'll start the solution. Uh, so first we can apply the method of joint to analyze uh, so first of all we have to find out the reaction force. So reaction force at RA, at A is RA, reaction force at C is RC, and this force is RA, and this force and the reaction force is C is RC. So to calculate the reaction, we have to taking moment at point A. So at point A, I have to take moment. So RC into 4, RC into 4 in clockwise direction. So we consider taking moment from A, and the distance is 4, and the force is going at clockwise direction. So force is rotating. Sorry, the force is rotating at anti-clockwise direction. So if you consider anti-clockwise is positive, then clockwise is negative. So RC into 4 in left hand side, and right hand side, or in right hand side we have our force 8 kilonewton. So 8 kilonewton into perpendicular distance. So 8 kilonewton taking moment from A, 8 kilonewton, and perpendicular distance is 1.5. So here 1.5 and 8 kilonewton. 8 kilonewton force is going this direction, and the height is 1.5. This height is 1.5. So 1.5 8 into 1.5, and this one is clockwise direction. So clockwise direction is negative, so we have to write this in right side. So right side it will be positive. So 8 into 1.5, and another force is just 12. So 12 is force is there. 12 into this one is 2. 12 into 2. 12 is force into 2 is perpendicular distance. 12 into 2. So 12 into 2. This is 36. So total it comes 36. So then RC will be 36 divided by 4 is 9 kilonewton. So RC comes equals to 9 kilonewton. RC is 9 kilonewton. So RA or RA or VA, whatever it is, RA equals to 12 minus 9. So 12 minus 9, 12 is downward. So here we can apply one assumption that all the forces, summation of all the forces at y direction equals to 0. So all the forces at y direction, what are there? 12 kilonewton downward. So 12 kilonewton downward, and RC upward 9 kilonewton. So downward is, if downward is positive, then RC is negative, and RA also upward, so it will also be negative. So RA is also negative. So RA equals to 0. So RA equals to, sorry, it will be RA equals to 3 kilometer, positive 3 kilometer. So in this method we have to find out the reaction force, and also we have to find out the reaction at HA. So HA, so this one is HA, horizontal force at A point. HA will be, so in same method we will apply summation of all the force in Fx direction will be 0. In that position Fx equals to 0. That position HA from right to left, if right to left, from right to left. So if it is negative, then left to right it will be positive. So left to right it will be positive. Which one? 8 kilonewton is positive. All the force equals to 0. All the force equals to 0. So HA equals to 8 kilometers. So H equals to 8 kilometers. So say here also H equals to 8 kilometers from right to left side. So it is very much important to uh, find out the reaction force at each and every joint to analyze a truss member. Without having this reaction force, we can't analyze the truss member. So for each and uh, every example regarding this truss member, the first and foremost thing we have to analyze the reaction force.